Okay, chalo. Let's solve some questions. This is the first example. The ground conditions at a site are as shown in the figure. The water table at the site, which was initially at a depth of 5 meters below the ground level, got permanently lowered to a depth of 15 meters below the ground level due to pumping of water over a few years. Assume the following data: unit weight of water is 10, unit weight of sand above the water table is 18, and below the water table is 20 kilonewton per meter cube. Find effective stress change at mid depth of the clay layer due to lowering of the water table. Okay. From this question, I'll give a tip and I will give a conclusion at the end. Or generally I can say the students will commit mistake in the calculation of pore water pressure because they don't know, or I can say some people, I don't say all the students, some people. So this tip can help because they can't imagine where the pressure head is, because pore water pressure equal to pressure head into unit weight of water. So the tip is, whenever you are solving pore water pressure or calculating pore water pressure, think that there is a piezometer. Place it there, and from that you can calculate. And one more thing is that if you place the piezometer and there is no confinement or anything, in that case the water level in the piezometer will rise till the water table. So the first case is, let's say initially he given that water table is at 5 meters from ground level. This is ground level. So here water table, this is 5 meters and this is 15 meters. You want to calculate change in effective stress at mid of the clay layer. So the change in effective stress equal to final effective stress minus initial effective stress. Okay. So in first case we'll calculate in these 3 points effective stress. Okay, because this is the first example. After this, in the case 2, we'll directly solve here because we don't need this point and this point. He wants change in effective stress at point 3 only, because so in that case this and this, if you calculate these two, there is no need to calculate, but this is the first question, so let's calculate. So effective stress at 1 equal to total stress at 1 minus pore water pressure at 1. So in total stress he given unit weight above the water table is 18, unit weight below the water table is 20. Okay, so total stress equal to gamma 1 into H1 minus pore water pressure gamma W into H1. This is not H1, let's say H, or simply it is better if you write like this. Excellent. Pressure head, very good. Okay, so gamma 1 is 18 and H1 is 5. minus gamma W is 10 given that it is 10. Don't make that mistake always taking 10 or always taking 9.81. He'll give 10 or 9.81. He'll give. If he not mentioned in the question, you have to take 9.8. Okay. Now, so the tip is, if you want to calculate forward pressure, let's place piezometer. So I said, in the piezometer level, or the water level in the piezometer rise till water table, but we placed at water table only. So it means that there is no level in the piezometer. It means that pressure head is 0. So in that case, pore water pressure is 0. So that equal to, this is 0 and this is 90 kilonewton per meter square. Now effective stress at 2, gamma 1 H1 plus gamma 2 H2 minus pore water pressure, gamma W into pressure head. So gamma 1 into H1, this same thing. So this is 90 plus gamma 2 is 20 into H2 is 15 minus gamma W is 10. And for pore water pressure head, you have to place piezometer here. In that case, the piezometer level will rise till water table. So this is 15 meters. So this equal to 90, 300. So 390 minus 150, which is 240 kilonewton per meter square. So the now sigma 3 bar effective stress at clay mid layer equal to gamma 1 H1 plus gamma 2 H2 plus gamma 3 H3 minus pore water pressure gamma W into pressure head, that equal to gamma 1 into H1 90, gamma 2 into H2 2 into 15. It means that 90 plus 300 plus gamma 3, this is also 20 into H3, this height 2.5 minus gamma W 10 into pressure head. If you want pressure head, place a piezometer here. So the water level in the piezometer will rise till that point where water table present. So now the height is 2.5 plus 15, which is 17.5. that equal to 90, 300. So 20 into 2.5, which is 440 minus this is 175, which is 265 kilonewton per meter square. So from first sigma three bar initial is 265. Now we'll calculate the second case. I'll calculate directly second case. Okay, we'll calculate directly sigma 3 bar effective stress at 3 final equal to, now the final case is the pore water pressure. Let me drop this. Okay, so the water table is at 15 meters from the ground level. So he given unit weight above the water table is 18 and unit weight below the water table is 20 kilonewton per meter cube. Okay, so now we need to calculate effective stress at mid of the clay layer. So gamma 1 H1 plus gamma 2 H2 plus gamma 3 H3, this is total stress minus pore water pressure gamma W into pressure head. Don't forget the tip. Okay, so gamma 1 is 18, H1 is 15, gamma 2 is 20, H2 is 5, gamma 3 is 20, H3 is 2.5. Write this here. So 18 into 15 plus 20 into 5 plus 20 into 2.5. Okay, minus 10 into, there is a tape where you want pore pressure, there you have to assume that there is a piezometer. In that case, water level in the piezometer will rise till the water table location. So here it is 2.5 and this is 5. So total pressure head is 7.5, which is equal to, this is 75 and this is 420. 420 minus 75 will get 345 kilonewton per meter cube. So the conclusion, I said I will give a conclusion. Sigma 3, effective stress 3 initially is 265 kilonewton per meter cube. Now the effective stress, that is final effective stress, is 345 kilonewton per meter cube. It means that as sigma 3 final, effective stress at 3 final is greater than effective stress at 3 initial, it means that due to lowering of water table, effective stress increases. Write the conclusion. Note, due to lowering of water table, effective stress increases. Okay, how much the increase? Increase in effective stress at 3 equal to 345, which is final effective stress, minus 265 kilonewton per, sorry, this is meter square, okay, which is 80 kilonewton per meter square.